Thank you again for joining today's MSDN webcast, a lap around HTML5, bringing it together, creating an HTML5 game. Without any further delay, it's my pleasure to hand the floor over to our first presenter. And Lindsay, you now have the floor.
Great. Thank you, Craig. Well, everyone, welcome to the last part of our four-part series on HTML5. And this part of the series, we will be wrapping up everything that we've learned by talking about some game creation. So I hope you had a chance to make it to the last three parts of our series, and if you haven't, please go on to the MSDN webcast page and do a search, and you'll be able to view the other parts of our series so you can get caught up and learn more about the components that make up HTML5. So with me, as usual, I feel like Wayne from Wayne's World, is Tara Walker, who is also an academic developer evangelist with Microsoft. And Tara will be going over some of the part of this presentation talking about one of the most excellent game libraries for creating HTML5 games. If you want to learn more about HTML5 and what we're doing with it and some of the resources for today's webcast as well as the rest of our series, you can visit our blogs as you see on the screen, blogs.msdn.com/Tara Walker or blogs.msdn.com/Lindsay, and you can see some of the resources, including the slides and links to some of the demos today, as well as demos and code from our past sessions. And of course, our email addresses are here, so if you have any questions from here on out as you explore HTML5, we'd love to hear from you and help you with your endeavors. Also, if you've written a game or you're doing some good experiments with HTML5 or you'd like to show off a little bit, send us what you're doing. We'd love to hear and see where you're going with this pretty cool and new technology. So in talking about games with HTML5, and specifically the graphics elements we talked about in our last session, the canvas tag as well as scalable vector graphics, you can really create some pretty powerful in-browser games. Of course, instead of just talking about regular programs, we're talking about games. So there's a little bit around that we need to think about when we're writing games specifically. And one of those things is the game loop. So the game loop is, versus running a regular, program that executes from start to finish and then everything's finished when it's done. A game loop is exactly that, a loop. So it's a little bit of a different programming paradigm. But the biggest thing to remember is that there are three things specifically that you need to do in a game. One is when the game starts, you need to load the content. So loading the graphics, loading the audio, and any other resources your game is going to use so that they're loaded up in memory and that your game can execute against them. So that's, of course, you have to do that. And then when you're done using these resources, you need to be efficient and release them. In games development, especially when you're talking about within the browser here, you need to be very efficient in how you're handling your memory and the different elements of your game so that your game is most performant. And in IE9, Internet Explorer 9 and 10 and beyond, since we do have hardware acceleration, you do get a really big hit with not a hit, that's the negative thing, but a really good boost in performance. But, if it's an HTML5 game, you want to make sure that it can behave properly in all the browsers that support HTML5. So you always have to, there's no, in JavaScript, there's no existing, this is my great memory garbage collection. You need to handle that yourself. So there are some game libraries out there which we'll talk about that help you out with some of that. So loading the content and managing the content. The other two things are updating and drawing. So you basically have to update the elements in your game world and what happens to them as they move across the screen, as they collide with one another, as the user takes different actions and does different inputs such as, mouse and buttons and arrow keys and all that good stuff, as well as just what happens over time in your game. You have to update what happens to every single element. Based on what the user is doing, you calculate the effects on the elements in the game, and then you you know, once the elements have moved around or collided or what have you, you need to draw them to the screen. So you just need to draw those different elements to the screen after they've been updated. And you have to do this continuously because things are forever changing. And when you draw, you're drawing a certain number of frames per second. We'll say 30 frames per second because that's what your phone will do. That's what you should probably do in your browser window. It's also what the human eye can perceive as pretty fluid. You'll also see based on, and some examples I'll show you, based on the hardware acceleration IA9 and some other browsers, you can see that the frames per second can slow down or speed up. And so, of course, you want to make sure that your game handles that effectively. And drawing, you're going to draw from 30 frames per second, but of course you have to clear the screen every time you draw. Or if you have a bullet going across the screen, you're going to see a trail of bullets. This is just a quick example of a simple game loop in JavaScript. So if anybody on this webcast has used XNA before, Microsoft's game development platform where you can write games for Windows, Xbox 360, and Windows Phone, you are familiar with the game loop and the different methods that XNA has for you to work in that game loop. However, with JavaScript, you're creating the game loop yourself and then managing the content and your resources and handling the drawing and the updating. So this is just a really short example of how you can create a game loop. First, we're defining the frames per second, in this case 30. On initialize and then init function, we're going to load our content and graphics, so load our audio files, get at our images, and then we're calling a function. Then we're going to start the game loop, and we're using the set interval function to iterate, to make it generate as 30 frames per second. So we're going to call our game loop function as many times as set interval gets called. So our game loop function is going to have two sub-functions, update and draw, or, as many as you want to, but just for simplicity's sake, update and draw. Figuring out what's happening to your elements in your game, and then drawing what's happening to the screen. One thing that you do have to do is for every frame, I mentioned this, you have to clear the screen, and by doing that, you need to reset the canvas. And by resetting the canvas, you're clearing all the elements from the screen. And on the canvas, there's no specific, function to do that or property to set that clears the screen or anything like that. But basically, whenever you're manipulating something on the canvas, it clears the screen for you. So one trick that we do is just set the canvas width, canvas.width, equal to the canvas.width. So it's just a quick trick to clear the screen there. So now I'm just going to go into a demo and just browse out and show you a little bit more about some game engines that we have available to us and some resources for you to take a look at to get started on game development. So with that, I'm going to go into all right, so I hope you can see my screen. Should be loading for you. Tara or Craig, can you just chime in to let me know when you can see it?
Yep, I can see it.
Okay, great, thank you. Yeah, I just want to make sure that I'm not talking and you can't recognize it. So in the slides, when you do a print to PDF, you will see on our resources slide, which is the last slide in this deck, a link to this page on GitHub. And this is just a page that BBraw has put together on different game engines available for JavaScript, for HTML5 and JavaScript. Now, again, with showing you the simple code on the screen, you can, just write your own JavaScript, and that's fine. But there's a lot of JavaScript libraries that can help you in that creation and kind of handle some of the typical game design and game mechanics for you. So what a typical game engine would do. And there's a few of them out there, and I'll go into them in a second, but I just wanted to show you a few other things. Chris Bowen, our colleague, developer evangelist here on the East Coast, on our team, also has had a great blog post that he just did recently, last week, around this content for the HTML5 game camps. We did them across the country, or sorry, I should say at least around the East Coast, and now we've done them in the webcast format. So he's put some resources up about each of the sessions that we've done, as well as, if I can scroll down to the last one, creating an HTML5 game, a bunch of the things that we're going to talk about right now. So I recommend you taking a look at that. The other one, oops, my bad. We've mentioned this every single one of our webcasts so far, is the IE Test Drive site. It's ietestdrive.com, which resolves to ie.microsoft.com/testdrive. And you can see examples of the different HTML5 elements that we've discussed. So touch effects, fishbowl, flying images, those are all really good. And one thing that Tara showed you in our last webcast is this Let It Snow demo. And here I just wanted to show you, this is using Canvas and SVG, and it's not a game necessarily, but it's using some of the same elements, so you can, and the audio, HTML5 audio, so you can take a look at all of these examples just so you can get a feel for how they're using SVG and Canvas to do these effects. And it does have music, but I don't want to bore you with that. If you take a look at the very bottom of the screen, there says More Demos. So when you click on that, you can see some graphics demos, HTML5 demos, and speed demos. So I would take a look at all of those because there are a lot of good fun things here. So Svg Helicopter, this is one game I just love. You're flying a helicopter, and I'm not using the right buttons here. There we go. I'm used to playing the classic one, and I always use the buttons versus the mouse. Anyway, so there are some games that already exist, and you can view their code, as well as just some use of the graphics. So I would take a look at that. The other site that we have that might be helpful for you is our App Hub, which is create.msdn.com. And this is our homepage for creating applications for Windows Phone, as well as Xbox 360. And, not that you're going to find all the HTML5 resources here, but this will teach you a lot about game development. So if you take a look at the game development section, it's all about using XNA and Silverlight to create games. However, we have a bunch of free samples of all different types of games, starter kits, and learning to work with graphics and different dev area, games, math, physics, shaders, collision. So a lot of stuff that teaches you about the logic behind game development. The other thing is there are lots of visual assets that you can use here that are published under the Microsoft public license. So whatever samples there are that include some, some sprites and some images and audio files and such, you can use them as long as you adhere to what the license says, but it's a public license. So that's one way you can get at some content for your applications, as well as understand the logic behind game development. So that's the App Hub. One cool thing is on the App Hub, you would see one of the examples that we have for XNA, which is called the Platformer Game. And it's this character that kind of looks like Indiana Jones who's running around and, jumping in diamonds, kind of like jump is W in this one. I always, by default, press the space bar. But, you can't really, I know one problem with this webcast over a live meeting is that we're talking about graphics and games and such, and unfortunately that doesn't come across really well over a live meeting, so you see it as being kind of jumpy and such. But believe me, it does work. So also on Chris's blog, you will see this link to the Platformer Game, which, I'm blanking on this guy's name, David Rousset, or Rousset, if you're so French, took the Platformer Game with XNA and ported it to using Canvas, the Canvas tag, and Easeljs, which is one of the game libraries that Tara is going to walk through. So it's pure JavaScript and using the canvas tag, so it's fully HTML5. And you can actually get at the source code, as you can see on the screen, and play around with this yourself. So take a look at that. Also on the IE test drive site, oops, I closed it, sorry. Also on the IE test drive site, there's a few more demos, and one of them is called the Galactic, probably under the more one, Galactic Demo. And it's one of the speed tests for HTML5. And it is basically, again, I know this is going to appear jumpy to you, but it's basically rendering out a solar system view. And it says there's, you can see it counting up in the bottom, 300, 400 solar system rotations with 21 frames per second at this point. But it's pretty cool and pretty fluid looking, and it's a little bit slow because I'm running over live meeting, but this is using IE9 and hardware acceleration to make it appear so smooth and great. You can run the same demo in Chrome, which I guess you can't see, so hold on one second. So this is it running once you see that load. This is it, the same one running in Chrome, and it's a lot slower, not because of anything going on with Chrome itself, but because of the hardware acceleration that is present in IE9, but not Chrome at this point. Sorry, just going back to my other one. Let me close that. But there is also on MSDN, part of the Internet Explorer team blog, they talk about how they built that demo with the 3D solar system and HTML5. So this one is actually using JavaScript game library called 3JS. And so this is using 3JS and on top of HTML5 to create that Galactic. So there's lots of resources out there for you to see where to get started. Take a look at games and such as that have already been running and see it well documented. Another cool place to go is canvasdemos.com. And this you can see some quick games and apps and tutorials that people have built around the Canvas tag. If you're going to use Canvas and not SVG or a little bit of both. And the latest tutorial is using 3JS. Yeah, so it's a pretty great one. Canvasdemos.com. And then lastly, one of the resources before I get into those JavaScript engines is makeawesomeweb.com. And makeawesomeweb.com is basically like Pinterest for HTML5 stuff, it looks like. It pretty much acts like. So a lot of great HTML5 demos and games and standards and testing things and all the good stuff at makeawesomeweb.com, all based around HTML5. So take a look at that to give you some ideas to help you understand, in this case, CSS3, and also understanding more of the JavaScript libraries and some, I like JStat. JStat does some more statistical things. They kind of load themselves all the time, but there's one I'm looking for that helps. Maybe I passed it. I don't want to. Oh, yeah, Buzz, which is an audio library, which is helps you when you're trying to put some audio behind your game. That's a good one. I know that scrolled pretty quickly, but one moved on me and I can't find it. Oh, HTTP Stat US. This helps you generate different HTTP requests and codes so you can understand how to do different responses with your HTML5 site. But anyway, just a bunch of little helpful tutorials and resources. Okay, back to the game engine section. Again, this link is in your slide deck. And this, lots of people have started playing around with HTML5 and creating frameworks around it, including some for use of creating games. And what I like about this site so far is it tells you the name of these different libraries and frameworks. It tells you how big they are. Most of them are pretty small. And especially what licensing this falls under, so whether or not you can use it in creating your games and such. It tells you what type of games or creates or what type of graphics it works with. You'll see a lot of 2D and you know, some documentation around it. So take a look at this. It's a great place to start. I'll walk through a couple of them. So one pretty popular one is Akihabara, and you'll really like this one if you really missed the 8-bit days of playing video games. And so take a look at Akihabara, and there's a few games that you can play for demos. Akihabara, if you didn't know, is a place in Tokyo, well, an area in Tokyo that's popular for shopping and shopping latest tech toys. So play around with Akihabara. You can view the code on any of these sites, and they will work in HTML5. You can download the core for Akihabara, and there's some links to tutorials on this page. However, there's a lot of tutorials you will find are outside of this. Sorry if I'm scrolling and you can't see that, but a lot of these are outside the scope of what he's done in the site. So if you just do a search for Akihabara tutorials, you'll find some. One great one is the Boston Game Jam. I don't know when that was. I guess it was in May or so. But Boston Game Jams, one of the presenters did a tutorial series on Akihabara, and it's a pretty good one. So take a look at that. I have it on the screen, bostongamejams.com/Akihabara-tutorials, and this will talk about using that from start to finish. Another good one is a pretty simple one, is Crafty. And if you notice, Crafty is only 8.7K, so it's a pretty small file, and it's very lightweight. It allows you to do some cool things like event management and simple things like collision detection. If you haven't if you haven't taken a look at game development before or used game engines at all, Crafty is a good one to start with because it's pretty lightweight and simple to use, as well as well documented. So, yeah, take a look at that. This talks about using Canvas as well as SVG. If you can see Canvas or DOM to choose your energy. Talks about collision detections and events. I mentioned there's a lot of tutorials, which is the first place you should start. Of course, there are demos around it. So if you take a look at, there's one called Fruit Assassin, which if you like playing, and I didn't look at the control for this. It should be my mouse, but it's not working. Unless it isn't. It is my, oh, I totally didn't know. There's like a Minecraft clone. This one's fun. Build some blocks. Oh, destroy blocks, build blocks. You can open my inventory. More ground and flowers. It's more ground. I'm not really good at this, but you get the idea, and seeing me play it is probably not the best thing showing on live meeting. However, it does work. So. Anyway, so you can take a look at some of those examples and tutorials here. Connect 4, which is one of my favorite games ever. Asteroids, which is fun. Of course, you can get to the code behind and take a look at it yourself. But that's that one's a good one. There's a bunch here. Easeljs, Tara's going to cover it momentarily because that's a really popular one. Notice some of these do require you to pay to use them. Enchant is one that I've seen and taken a look at before. You can get to most of these you can get from GitHub. There is one that, of course, if you've done any game development before, it's probably a natural fit. Would be, sorry, I'm scrolling down here, Unity 3D. So Unity 3D is a commercial game engine that different developers have used. So you can use Unity 3D to create web games with HTML5 as a supported game engine. However, it might be overkill if this is what you're starting with to learn HTML5 game development. And let me see, there's one more that I wanted to show you. I'm trying to think of it. Sorry. Yeah, I'm going to go show you 3JS. That was it. Okay, 3JS. Somehow, can you see my screen right now? I can't tell.
Yes, we can see it.
Okay, great. So 3JS is another one, and this is a great one because, and this is linked to from the page. This is a great one because it is a 3D, it basically takes 3D and renders it in 2D. So you can actually create some really cool 3D sites and tests and everything using the context 2D of your canvas. And this is also the same, if you take a look at one of these, the geometry Earth. I know it's going to be choppy for you, but this is an example of the 3D rotating Earth. This is one of the examples. This is using the Galactic IE test drive demo uses 3GS, and actually specifically this geometry Earth piece. There's a couple ones that are my favorite. The terrain demo is a good one. Of course, you can see the code, but you can. This is 2D using the 2D context, but this 3JS is taking 3D rendering. So kind of one term that they use for it is 2.5. So it's kind of a cross between 2D and 3D. Another great one is the Panorama Sky View. So you can scroll, see the sky in your world. And it's basically just taking a bunch of images and stitching them together to make a panoramic view of your world. So a lot of really powerful things and thankfully, some great demos and tutorials to help us understand them. And you can see some of that in the library. There's one, I forgot to show you some of the code on one of these things. So in the Canvas demos I meant to show you, if you look at the most recent one, the 3JS tutorial, it does walk you through exactly every step to take and the code. So you can copy and paste this into your browser or use different pieces of it to learn from. And most of these game engines have demos and tutorials on their sites with the code behind. Actually, they all should have the code behind for you to take a look at. So get started here, jump into game development, and take a look at some of these tutorials. But let's dive a little bit deeper into one of them, which I didn't get a chance to talk to, and Tara will address right now, which is called Easeljs, and it is one of the more popular HTML. That's what I was going to show you before we get there. Sorry. Let me show an example of this in use, Easeljs. Sorry, Tara, I forgot I was going to show that. So pirates love daisies. So Pirates Love Daisies is a game that was created by Grant Skinner. And sorry, it's loading for the first point. And because, of course, pirates love daisies. It's an HTML5 game. And in creating this game, just from what he learned and his team learned about creating it, is out of this game creation came the Easeljs JavaScript library for creating games. So in the creation of this game is something they learned and repurposed for everyone to use. So this is just show you this game really quickly about letting us do some things like adding a few people to our map. And the sound's not on because, again, it's really loud, but I'll turn it on for you. But the Scarlet's a crack shot, and different waves of these critters. And it's because they don't want these critters to make it to their daisies. So and before they can get us. Anyway, so it is kind of an addicting game. Now this one's crossing the bridge, so I need to shoot him. Oh, there you go. And so you can take a look at pirateslovedaisies.com and play around with it, and that helped in the creation of Easeljs. So with that, I'm going to go back to our slides and hand it over to Tara to talk a little bit more about Easeljs and walk through the actual JavaScript.
Okay, excellent. Hi, everyone. So as Lindsay noted, we're going to talk about Easeljs. Now, the great thing about Easeljs that we're going to get into is if you are truly interested in creating a game, they've really designed a lot of their libraries specifically to help you in the game with the game loop and doing things that are typical to the game loop functionality that Lindsay talked about. So init, draw, and update are the typical game functions or methods that you call repeatedly to create a game. And Easeljs does a great job. This is a free or open source library that you can leverage in HTML5 to create really rich and robust games. So let's go over really quickly some things about, Easeljs. First of all, really extending the canvas element on your own can be difficult, especially if you're talking about building a game. So the great thing about Easeljs, it gives you some main objects that you can use to aggregate things over the course of your game and the life of your game, both from event handling and to initialize game loops and tickers and frames per second. So let's go over some of the main elements. First of all, the main base class for Easeljs that you'll see used throughout, not explicitly, but most of the main other objects are extended from it, is called the display object. And as I noted, this is the base object. So it does the typical things you would note, detect, you can do things like X and Y, scale X, scale Y, alpha, shadow. And these are just common things that are, innate to all display objects. Again, this is the base class. You would never really use display object innately or explicitly, but just kind of let you know, most of the things I'm going to talk about next will return something extended from base object. One such class is the stage. And the stage is a container. And so actually I should have flipped these around and talked about container first because they extend stage. But a container simply is a display object, and you can group different display objects together. Let's give you a great example of that. Let's say I was working with a game and I had a person. And I may decide that in controlling this person in the game, having a person container, I might want to treat the arm separately. Maybe it's the claw arm or something, and I want that to treat that a little bit separately than I do for the rest of the person. But I want that claw to still be a part of what we call the person container. So I may have an arm object, a leg object, a torso, and all these different bitmaps that I piece together to make the person. I can piece those together and make them, treat them, and transform them as a group by using a container. Now, the stage extends then the container class and groups all the display elements together in general. So the minute I start off in using Easeljs, the first thing I typically do is set or extend the stage by passing in the canvas. So this is the grouping of everything. So stage for the first step that you're creating a game using Easeljs. You'll see it used in all tutorials, and the one that I'm going to show in a few minutes, you're going to see that the first thing I do is pass in the canvas. So everything associated with the base HTML5 canvas object, well, now I can treat this as a container in the mantra of stage. Now, what does stage give me? The great thing about Easeljs, it takes the canvas that I passed in as a stage, and it gives me a ton of different properties, events, and methods that I can use. Things like mouse down, mouse up, so events, mouse move, things that I typically would have to create myself. I have that event that it can track and add a listener. Things like double click and the like. Also, a great thing about the stage that Easeljs gives us is an update method. And the update method will actually render on a frames per second. Now, having the stage also allows me to initiate a function that gives me the get frames per second. That's also a part of Easeljs. So let me change the slide here so we can talk about some more of these functions. All right. So as I start to really look at, the Easeljs, it also gives me different things that I typically would have to create and use myself. Text, so rendered text in the context of the display list of the canvas. Bitmap, I can draw an image or a video to the canvas according to its display properties, or add a bitmap into a container of the stage and have multiple containers of bitmaps. I can sequence, and this is one that's very powerful, where I can display animated or dynamic sprite sheets by using it multiple frames on a grid. I can do playback and sequencing, and these are all things that are already available for you in the Easeljs library. Graphics, very powerful API for dynamically drawn vector graphics, and shapes, so you can render different vector art using the graphics object using Easeljs. So hopefully you guys can see my screen change here. So I'm going to actually stop here before I go over the rest of this overview and show you a demo, because it's great that I'm talking about all these wonderful objects, but it's also even better when you can actually see them running. So let's first do a quick intro of Easeljs. And if you came to any of the previous presentations that we did, you would have seen this demo. So I'm going to just simply extend this past what you would typically see. But for the first Easeljs demo, first I just download the Easeljs library, if you could see my screen, and I included it into my Visual Studio project of my web application. And this Easeljs demo, what I did was init function, simply just as Lindsay talked about. I set new text, and again, that's the text object I said I have available to me. I created a stage, and I talked about that, and I passed the canvas into the stage, and now I can treat these things just like any other class object that you would use. Here I'm creating an image, and I'm going to actually move this image. And I'm going to set the image and say, hey, anytime a mouse event fires, hey, move this image over. Another method that I didn't talk about yet that is going to be really powerful with Easeljs is the ticker. And the ticker is a static object that gives you various things like an add listener. So I'm an add listener for the windows of the actual things like the mouse events. But this ticker, when you initiate your own method called tick, will actually make a frame. Once you set the frames per second, it'll actually update based upon frames per second. Now here, let me make sure you know that you see the tick function here. You have to instantiate or create, rather, a tick object yourself and put any of the logic, game logic that you want in there. And here I'm not doing a lot here. I'm just going to take that logo of that text from that bitmap image, and I'm just going to move the text coordinate to the left by subtracting 2 each time the tick is called. And again, the tick is called based upon the frames per second that I set. And then once I do that, I call the stage update, again, simple to the same game methodology, and update and draw. So it will refresh my screen and cause that to move each time. You'll notice that in the base HTML, only thing I'm calling here is a canvas with the width and the height, and that's the only thing you'll see that. And I note that on load, I want to use an init function that I created. So very simple. So let's go ahead and run this. Let me set this as my start page. And we're going to compile. And for some reason it's not showing on my screen, so hold on one second. Let's do that again. Lindsay, you guys seeing it?
Not yet. It's still a gray screen.
Okay, so let me try that again.
Oh, there we go.
So I'm gonna
We can see it now.
you can. So let me
Yeah.
share it again. Let's try this one more time. So let me compile again. All right. You guys see it on the screen?
Yeah.
Great. All right. So as you see, that was really simple. All I did was take a hello world, and I'm moving it across the screen. Nothing special there. So let's go back to the code here. All right. So this is just a really, really simple example of Easeljs. Now let's talk about something a little bit more robust with Easeljs. So let's move back here. Oops. All right. Show that deck again. Okay. So here, you note I use the text. I use the bitmap to draw that image of going across the screen. I use some things around the graphics object, and I just display that going across the screen by manipulating the x-coordinate of that image to subtract 2, right? So let's talk about a little bit more complex things around it. All right, the next thing I want to do with this is let's actually create a much more robust game doing this. So let me share out my code again. All right, so let's look at starting a game. So here I'm going to really create just a simple game using Easeljs where I'm going to create some ships on a screen, and using my mouse I have to make all the ships or click them or fire them away before they get to the end of my screen and I lose, right? So the first thing I'm going to do here, again you should see a pattern here, I'm going to create an init function, and then I am going to set my stage and pass in the canvas element. I'm going to keep score here as well. So you go down, I talked about the image function, so I'm going to create a new image. I'm going to load that new image as a planet image I have in my references, and on load I'm going to set the background, and that's another method I've created. I'm also going to go ahead and load my ships, and on load of the image it's going to create those ships. So as I start this, again, setting the background, I'm testing for the onload events. The background is going to say, hey, create a new bitmap. We talked about that object that's available to you. I pass in that background image, and then I add the background as a child object to my stage, and then I update the stage. Again, update needs to be called, like any game loop, so that it'll update the screen. The next thing, if you notice, I am going to create some ships, and I'm going to store it in a separate container. So the ships will be grouped separately as a part of the stage that I'm adding. But again, just group all the ships together. So I create the ships, the event target, that I pass in. I'm creating this new container, and as a stage, I'm adding the container. So this is a container of ships that is now added to the stage, a group of ships if you want to look at it that way. So I start to create ships here, and if you notice here, I'm setting X and Y, giving the ship name ship plus is number, so it'll be ship 0, ship 1, ship 2, and creating an array of bitmaps of ships, and then I will update my stage to show those ships. When I need to reset here, and I actually swipe a ship, you'll see that I'm going to pass in the ship that I'm resetting and get rid of that ship by doing some mathematical functions. So this is just the start of the game. If you note here, right now I haven't done any input. I'm just creating the base start of the game. So let's run this and see what this looks like. All right. All right, so right now, as you see, all I've done thus far is I've created my background, as you see, as a part of the stage. I've started to load the ships in random positions. And so now we're starting the game. Now, what I said I wanted to do was take in input that when these ships actually move, that I was going to click the ships to go away before they got to the end of my screen, and therefore I lose. So let's go ahead and complete that as well. So let's go back to my code. All right. So I've done some of the work here by adding the ships. The next thing I need to do is really make not only the ships move, but to actually accept content, or input in from the users about my ships. So let's look at the rest of the code that I would need to do. And again, there's a lot of tutorials you can use here that I'll show at the end of this. Well, the first thing I'm going to do is take a canvas on mouse up and down. So I'm going to take those events that's a part of the mouse up and down, and I'm going to set them to my Easeljs on mouse down and on mouse up methods that's a part of Easeljs. Okay? Then I'm going to, you saw where I already created the image and the planet. That hasn't changed. The background hasn't changed. The create ships hasn't changed. But I'm putting in a few things here. First of all, I'm going to show the score. Every time I swipe, I'm going to update that score so that it shows at the top of the screen. And you notice that I have the text baseline. I'm using that text object I talked about. I want the baseline to be at the top. I set the X and Y, and I set this new text as a part of the stage. I'm saying, hey, we're playing as a true Boolean there. And I set my ticker to add listener so I can track those different events that will fire. So again, here, now I'm adding a score. I showed you the reset enemy ship before, but now here's the fun part. Remember I said as a part of Easeljs, once you instantiate the static, and let me go back, you would never do a new ticker, by the way. It's a static method. You would just call it a static class. You never do new, so you don't need to instantiate it, and it gives you lots of power. Once you set the ticker.addListener to the window, the one thing, as I noted before, you need to initialize yourself is the function tick. And that tick is going to fire at a frames per second. And frames per second is also one of the great functions it provides you with Easeljs. So again, I just want you to note the method we're doing so far. I have an init function. I set the stage to the canvas. I create my images for the ships, and I'm setting my background. This is those methods. I'm creating my ships, and again, adding them to a bitmap array of ships, and adding that to a container. So I have a ship group that's a part of the stage. I created a new text object using the text class from Easeljs so I can track the score. And then I start the ticker so I can have a frames per second available to me so that it will fire my tick event every time the frames per second is up. And you can set the frames per second as well. I'll show you that in a minute. So every time the tick method is called, I'm going to check for a click event, see if I clicked on the click event. If I have clicked for the click event, the stage has a great function or method called getObjectUnderPoint. There's another one that's called getObjectsUnderPoints that'll return an array. But since I'm just looking for one object, I'm just going to do a getObjectUnderPoint. This is going to return a display object of whatever object was directly at the point of the click of the mouse of the X and Y. So at the stage, I just pass in so it's exact the X and Y, and getStageUnderObject will return a display object of that target, of one of the display elements. This one will just return one. The other one will return an array. So again, it's two, getObjectsUnderPoint and getObjectUnderPoint. Again, I just want one here. I'll take a moment to say this. This is a very expensive as far as resources call. So you want to make sure you handle this correctly. And again, the best place to put this is not in a mouse event and everything else. It really, especially in a game, and you'll see this if you really go under Easeljs and really dig into it, it'll note this. The best place to put this expensive object is under tick that'll fire just at the frames per second when you need it. So be mindful of using getObjectUnderPoint. Make sure it's used at the correct moment, it is an expensive method to call. So as I continue on, I checked that I had a click. It was clicked. And I have an actual mouse target here, so I have something that was returned, so something was actually underneath there versus just the image. And then I look for the text of the mouse name. And remember, my array of mouse names is ship 1, 2, 3, etc. I look for a substring of make sure this is a ship that actually is under my mouse target. And if so, I am going to reset that enemy, so get rid of that one, and give myself a score of 50 because I got one, and set clicked back to false. Also under tick, which is, again, this is just using the game loop methodology, I'm setting if I'm still playing and a game is not over for me, I am going to check out, okay, look at my bitmap, the length of it, and make sure I increase the speed. So I have 5 initially. So for each of them, I'm going to have it move 200 to the left. If you notice, I'm manipulating the X, and then I'm adding a speed there. Else, if I don't have any ships left, the game is over, right? I'm setting the text of the text to the score based upon me updating if I hit something, if I didn't hit something, and then I'm updating the stage. The last thing you'll see here is my game over. Hey, the game's over, too bad for you, but hey, you can play again. So I'm setting the game text here, creating a new text object, saying the game is over, saying you can play again. I'm aligning it with the center, and I'm setting the X and Y to the canvas height and width, again, so the center, and I'm adding this game text as a child to the stage container. I'm saying play is false because I'm done. And then I'm resetting all the enemies. So in case I didn't get rid of them all, and I just got one did make it all the way to the end, I'm saying, hey, you lost because of it, and resetting all the rest of the ships to go away. And then I'm updating the stage and updating the click to handle it. Here you notice handle click says now on click is null. I'm removing the game text and the score is 0 just in case we want to start again, because again I said if you want to play again, hit click. So I handle that and I reset the game and start over. All right, so we just added a few methods there. All of these things are using the Easeljs objects, making it very easy to initiate the frames per second by using tick, updating event listeners, and the like by using this. So let's run this and show what it looks like now. Let's stop that. All right, so let's run this with our updated. All right, now I have some moving ships. I click, I didn't get that one. The game is over. One reached the end, and I wasn't fast enough. So let's start again, see if I can get it quick, moving quick. This one moving fast. All right. And once I get them, so I'll let this one go to the end, the game is over. I got 300 score. So you notice that was a quick game, relatively simple comparatively speaking, of some of the things you don't have to handle in code that Easeljs will. Things like get frames per second, adding text to your backgrounds, having the ships be its own grouping container, the game is over, being able to instantiate the loop again, start your game all over, and things of that nature. So very powerful Easeljs for creating a quick game. And if you know, it really wasn't a lot of code that I had to do to actually make that happen. So let's go back to our PowerPoint there. All right. So you should see back on the screen. Again, it's wrapping the canvas calls for us to use. Works just like a stage. If you are used to using Flash, this will be very similar. The stage is only rendered or shown a display again when you hit the stage.update. The ticker class handles the time management. And again, it's definitely frames per second. If you use Flash, it's very similar to the interframe event in Flash. The Easeljs library, if you want to get really familiar or much deeper into the APIs that are available to the Easeljs, I just showed you very few. but there's a lot more functionality in there. Things like adding touch and filters and more graphics and things of the nature that you can use. Definitely check out Easeljs for the documentation of the class libraries. That is the link that you see showing right now. And then I've shown you Easeljs in action along the way in creating this simple game. There are a lot when you go to Easeljs. There's a lot more things for games. Lindsay showed you the game library. Easeljs is what I just showed you. She showed you the XNA. And hopefully you'll take advantage of the example of transforming some of those XNA-based games into HTML5 by David Rousset. Tons more framework. Take advantage of the IE test drive. And with that, I've concluded my demo on using Easeljs. All right.
We'll hand it back over to Craig then,
yeah.
and Craig can wrap it up. Thanks so much for attending this fourth part of our series. And please take a look at the links on the site as well as our blogs for more information. And let us know what you're doing. So thanks, everyone, for attending. And Craig, I'll hand it back to you.
All right, fantastic. Great presentation there. I'm going to go ahead and pull up the survey slide. You probably just saw that appear in your slide area. Please do take a moment to fill out today's survey before you log off. The feedback that you provide allows us to further hone down our sessions and create a better webcast for you. So we do appreciate you filling that out before you leave today's session. With that, we would like to thank you again for joining today's MSDN webcast. For more sessions, please visit Microsoft.com/webcast. Thank you again to our presenters and to our attendees. You may now disconnect from the audio portion of today's conference.